Okay, for the introduction, my research is actually about programming course, programming fundamentals, where from the literature review, I found out that programming is among the most challenging lesson among the beginners. Programming is not only about writing the program, but it also integrates problem-solving skills and also writing program. There are always happen misconceptions among the beginners, the novice programmers, due to wrong mental models. The novice programmers always have the difficulties in problem solving, where they are having problems in extracting the important data from the problems to design the algorithm. Despite many tools that has been proposed in many studies and research, programming remains a challenging course in every semester in the IPT lah, not only in Malaysia but all around the world. So my research background, I have summarized my research background to 6 points. So the first is I would like to emphasize that programming has always been reported to get high failure rates. High failure rates for C programming course with a worldwide passing rate estimated to be 67%. And then I focus in Polytechnic from study by Siti Rosmina Makdarus. She reported that more than 50% of students from 3 different diploma programs in one of the polytechnics, one of the polytechnic is PISAS, Tanjung Malim, achieved below satisfactory level, which is below 3-pointer. Okay, this situation is actually related to lack problem-solving skills, where they have difficulties in extracting the problem to adapt to the computational thinking. And Dick et al. 1999 suggested that a particular problem-solving model should be applied to learning programming. And apart from lack problem-solving skills, the situation is also as effect of difficulties of syntax. C programming is among the difficult programming language because of the syntax, and the low achievement was related to their difficulties in understanding the program syntax and semantic, and thus they are unable to produce a good program pragmatically. And then the research background also concerned about the knowledge application, the programming knowledge application, where in the course there is a mini project which is expected to be presented by week 14th of the semester. However, according to Rahmat et al., she emphasized that students cannot be expected to be skilled in programming within 14 weeks. So we've been studying how we can improve students' understanding in programming to be better in 14 weeks. And the research also focus on the learning medium that has been used by the students, which is the IDE, the Integrated Development Environment. Practically, the students, they do programming in a program development environment, namely IDE, such as Dev C++, Microsoft Visual. But actually, IDE is meant for software developers who are advanced or expert programmers and have good programming skills, not for the novice. And it tends to be overwhelming, according to some research. Okay, the problem statement for the study, for the research is, No, there is no problem-solving tool that the students can use in learning programming. As I have mentioned in the earlier introduction, programming is not about writing program only, but it also involves problem solving. But there is no tool for problem solving, and the students rely on the lecturer to guide them in identifying the problem, to formulate the problem, and plan the proper solutions. Then there is also no visualization tool for the students to have proper mental model to understand how the program is being executed in the computer. So the students could not visualize the language structure and memory operation so that they know what the program should be doing syntactically, semantically, and pragmatically. So they don't have the mental model of how the program is executing, how the computer is executing their program. And the third problem is the IDE that they are using is complex. The overwhelming IDE is meant for professional programmers lah. So with these difficulties, there is a need for a pedagogical IDE to be used in learning programming for the beginners to help them to introduce them to the programming before they really use the professional IDE. Okay, the research objectives. The first objective is to investigate the students' difficulties in learning programming. Second, to investigate the suitable approach to overcome students' difficulties in problem solving. Third, to design a pedagogical IDE that integrates guided problem solving tasks and program development with a visualization tool. Fourth is to develop a pedagogical IDE that integrates guided problem solving task and program development with a visualization tool. And last, the fifth research objective is to evaluate the usability of the pedagogical IDE in guiding problem solving and understanding C language. Okay, the research question that address the research objectives are, the first one is, what are the difficulties of students in learning programming? Second is, what is a suitable approach to overcome students' difficulties in problem solving? Third question, how will the software be designed to guide the problem solving and visualize the program development environment? Fourth is, how will the software be developed to integrate guided problem solving and visualize the program development? And the fifth is, to what extent is the software usable in guiding problem solving and understanding C language programming? This is the theoretical and conceptual framework where throughout the research, I will be doing according to these 5 phases of software process model, which is waterfall model. So I have adopted a waterfall model because the research will be conducted sequentially, phase by phase. So the first phase is software requirement analysis. To determine the software requirements through qualitative exploratory case studies to get the specification of the software. So after getting the specification of the software, we will move to the next phase, which is the software design, to determine the C-Solvis design. And then after we determine the C-Solvis design, a prototype is expected to be produced and will be checked with the stakeholders. And we will move to the next phase, which is the software implementation. That is the phase where we develop the C solvis. We develop the C solvis by units, components, and then do the component testing, integration testing, and then we will move to the software deployment, where after the software is released for alpha version, it will be tested for usability evaluation. And then from the usability evaluation, we will make some modification and improvement during the maintenance phase before we go and release the beta version of the C Solvis application. It is a standalone application actually. This is not web-based. The significance of the research mainly on three targeted groups, which are the first, the students, where we hope that this application can prepare students with a strong foundation of programming background and problem-solving skills. Second targeted group is the lecturers, where we hope that this IDE, this pedagogical IDE, can save their time, because most of the time the programming lecturers been drawing some graphics to show the computer working when the program is executed. So by the visualized version of the execution will help lecturers to explain better. And third groups is the software developers, where we hope that this research will serve as a guidance and reference to innovate in pedagogical IDE. I mean the development framework, so that the software developers can have the idea on how pedagogical IDE should be to provide better environment for the beginners, the novice programmers. This is the literature review. I have summarized my literature reviews to some points, to the main points. So the first I would like to introduce in the literature review, of course, the ontology of C programming, so that we know what we should cover when we want to develop a software related to C programming. So we need to know all the related terms that should be there in the software. And the literature review would cover the problem-solving part, the C language difficulties, and also the programming environment, the IDE. So what we have focused was during the problem solving, we have found that students are having difficulties to formulate the solution, plan solution, design solution. So this will be the base of the discussion with the stakeholders, where we found out that the problem solving and the C language difficulties, the C language difficulties are syntactically complicated for novice. It is difficult to understand conceptually, that lead to misconception. It is abstract and dynamic structure. So to link these two, there should be embedding the roles of variables in the research, and also computational thinking to relate these two. And also to relate to the IDE, we have found that the IDE is lack of visualization that leads to misconception. So we will do some study on how visualization is done in previous studies, and how the difficulties to translate algorithm into programming terms can be done. And also we have looked how the IDE is overwhelming and complicated, so that we are not repeating them in the IDE. So the IDE is targeting to be a simple one, which is easier for the novice, so we can reduce the cognitive load on them. Okay, so the literature review is continued uh, to integrate the problem solving task and the program development task, integrate them to be one application, because usually application is only focusing on the program development task. So in designing this, we have to take into account to consider these three elements: the computational thinking, roles of variables, and also visualization. So we have seen some related works on programming visualization application. So please focus on the PV. This is PV. So the first one, we focus on four works have been done in visualization. The first is online Python tutor. Is quite famous online Python tutor, although it is named Python, but actually it also has some application for C, but it's very limited because it can't be used for scanf and printf function. So this is some limitation of the Python tutor. It also has no problem solving tool. It only has program development tool. Second is the CC visualization tool. CC visualization tool is actually a good visualization tool, but the difficulties in installing the software has been an issue discussed by many researchers, because to install this, the user needs to install the compiler first. So this is also not being a favor to the beginners, because they are new to the programming. This will be the reason why they are not going to use an application. The third programming visualization tool is the Play Visualizer C, PVC. So PVC is also one of a good visualization tool developed by Japanese Ishizu 2020. But also it has no problem solving tool. It only has the visualization tool. And last but not least, the VIP Visual Interpreter. Visual Interpreter you can get from the website, but it has some drawbacks, because it is in the native language. I'm not sure what language is it, but it is not user friendly for English user or Malay user. Okay, I have also reviewed some related works on visual programming, VP. It is different from PV just now. VP is famous among the novice programmers in the primary school, because of the advantages and the characteristic, which is using block-based coding and drag and drop feature. So the user has no worries about syntax. They don't have to type the coding. They just drag and drop the blocks and create their program, and see the animation done just by dragging and dropping some blocks and just editing a bit. So some examples are Greenfoot, Alice, Scratch. It focuses only on programming algorithm, less on the syntactical issues, very user-friendly even among kids. But the disadvantages, it is not an industry practice. It is not suitable for the learning of C language because it only focuses on implementing solutions. It is not suitable also for higher education students. It does not develop one's ability to formulate problems, design solutions, and generate algorithms. And eventually, the students need to face text-based programming. But the VP is good to nurture the computational thinking among the students. Okay, then I have also made the literature review about how the software is developed. And here is one of the SDLC software model, which is the waterfall model. I have already compared three types of software process model, which is the waterfall, the spiral model, and I have chosen to adopt the waterfall model because it is sequentially arranged phase by phase. Okay, so the research design of this study is mixed method. Mixed method because we have different sets of research design in every phase. The first phase, the software requirement analysis, will be conducted by qualitative exploratory case studies to find out the software requirements, while the software design will be done through qualitative grounded theory by theoretical sampling. The development also will be done through qualitative grounded theories, and the C-Solvis usability evaluation will be done through triangulation method, quantitative triangulation, through cross-sectional survey and expert validity test, and last, modification and improvement. I have chosen the grounded theory because the design and development process is something that we are not certain about the end product, the end theory that we are going to adapt. So we need to have experts' views through theoretical sampling so that they would guide how the design should be and development should be done in the correct procedures. Okay, the participants. This is the research participants of the research. Okay, I think I would go to this table. Okay, so this table will summarize on the research questions, research method, research approach, and the participants. So the first phase will answer two research questions, the difficulties and the approach, by qualitative exploratory case study. Here, I will conduct semi-structured interviews with two programming lecturers with more than 10 years experience to know why the students are having difficulties and what are their suggestions to overcome the difficulties. And also, I will do unstructured interviews with maximum variation sampling from 3 students of three different classes with highest score and 3 students from 3 classes with lowest score to identify and investigate why the course, the programming course, is tough to them and why it is easier to certain students. Okay, the third question will be answered in software design, how the software will design through qualitative grounded theory by unstructured interviews and prototyping with theoretical sampling, 2 software practitioners and 2 programming lecturers. The development also will use qualitative grounded theory using unstructured interviews with 2 software practitioners. And the fifth question, to what extent is the software usable will be answered by quantitative triangulation method via cross-sectional survey. The questionnaire will be distributed to semesters to students from DET, DEP, and DTK classes after they use the CSolve software. And also, I will do the expert validity test from 2 software experts. Okay, thank you.